to the GeoERA final event. The ERA-Net on establishing the European Geological Surveys research area to deliver a geological service for Europe was established in 2017, bringing together 45 national and regional geological survey organizations from 32 European countries to collaborate in a joint geoscientific research program, the first of its kind in Europe. The vision of the GeoERA program was to establish the basis for a common European geological knowledge base and to encourage joint research in support of European policy priorities. With the projects now publishing their final results, the event will showcase their results and achievements. Moreover, the event will discuss the impacts this degree of pan-European collaboration by national scientific institutes can have on political, scientific, and social levels, and how geoscience knowledge and data can contribute towards the goals of the European Green Deal. Please accept my regrets that due to the pandemic situation, we are not able to hold this event in personal presence in Brussels as planned for a long time. The situation forced the organizers to go online. My special regrets go to the Geological Survey of Belgium, whose 125th anniversary cannot be celebrated together with the GeoERA final event. The celebration will be postponed. Let me express at this point my congratulations to the anniversary and good luck for the Belgian colleagues. So this slide gives some rough information, some cornerstone on the GeoERA. It was a 30.3 million euro research program under the Horizon 2022 ERA-Net co-fund action. We had 47 participants from 32 countries. One third was co-funding by the European community, and 2/3 were funded by the participants. The project started in January 2017. The project worked on 4 themes, 4 geoscientific themes, and it was performed in a 2-stage call. Within that 4 themes, we worked on 15 projects, and the kickoff projects started in July 2018. Next slide, please. Yeah, why a geological service for Europe? The answer, in my understanding, is simple, because geology matters in terms of creating a sustainable future for Europe and all its related partners. And this is a multi-phase task. The subsurface holds indispensable resources for industries in Europe and opportunities to decarbonize our economy with regard to climate change. The subsurface also requires careful management to preserve a healthy and safe living environment for Europe's citizens. And these 2 aspects sometimes are fighting with each other, and it needs research in data, information, appraisal on a high scientific level to end up in good sustainable solutions. Therefore, we need permanent available geological data and information services on the sustainable and safe use of the subsurface resources like geothermal heat, pore space for storing energy from renewable sources, minerals, building processes, and at least clean soils and groundwater for the prevention of livelihood. To provide European institutions, enterprises, authorities, and citizens with up-to-date, high-quality information. So, the scale of many societal and economical relevant geological features exceeds that of the individual EU member states. Just as in case of water, nature, food, production, or climate. Groundwater flow does not know political boundaries. Groundwater flow only respects hydraulic and geological boundaries. So we need to enable ourselves to zoom out beyond our national levels, and this requires innovation. It requires at least standardization and harmonization of data and informations because all geological survey organizations in Europe have their own history of describing geology, of evaluating geology, and it's the task to bring that together. And bringing together is overarched by a common shared vision. So at this point, I will hand over to Jo Passelman from the Dutch TNO, who had the project lead. Jo, please go ahead.
Okay, thank you, Ralph. Yes, next slide, please. Well, as you mentioned, my name is Joop Hasselman. I'm the project coordinator for GeoERA since 2020. And let me briefly introduce you to some of the GeoERA features. 4 themes are central to GeoERA: geoenergy, groundwater and raw materials, and the overarching theme of information platform. Although each of the theme boxes in this slide has resources listed. Oh, please, can you go back? One more. Although each of these theme boxes in this slide has resources listed on top, GeoERA is much more than simply mapping of resources and gluing together fragmented pieces of data. In case of geoenergy, we also looked at storage capacities, potential hazards and environmental impacts that may result for the sometimes conflicting and multifunctional use of the subsurface. In case of groundwater, we try to get a better understanding of groundwater systems, the interaction with surface water and ecosystems, and ways to better protect and manage groundwater bodies. In the case of raw materials, GeoERA also dealt with mineral intelligence and the sustainability of supply, with minimal HSE impact, health, safety and environment impact, and about spatial planning of both the surface and subsurface. In the information platform, all data, interpretations, models and information are brought together. Next slide, please. And all this has led to the definition of 15 different projects, 6 under the theme of geoenergy: HIKE, GERA, GeoConnect 3D, Muse, Hotline and 3D GeoEU, 4 projects under groundwater: Hover, Vogera, Resource and Tactic, 4 projects under raw materials: Eurolithos, Frame, Mindacy and Mintel4U, and the overarching GIP project that is building the information platform. Next slide, please. As Rolf mentioned during this introduction, 47 organizations have collaborated in GeoERA. It is an impressive achievement that this has happened. But at the end, cooperation boils down to people working together. I would therefore like to mention the names of colleagues without whose boundless effort this never could have been achieved. To start with, the 4 theme coordinators. Next slide, please. Antje Wittenberg for raw materials, Sesje van Gessel for geoenergy, Klaus Hinsby groundwater, and Jurgen Toelstrup for the information platform. I would also like to mention the project leads. To me, they are sort of the real heroes of GeoERA. Next slide, please. Daniel Oliveira, Javier Gonzalez, Tom Heldo, and Lisbeth Flint for raw materials. Next slide, please. Gregor Kutzel, Hans Doornbal, Stefan Knopf, Niels Hemmingsen, Gerald Diepolder, and Renate Barros for geoenergy. Next slide, please. Peter van der Keur, Laurens Corrie, Marco Bianchi, Hans-Peter Broers for groundwater, and Jurgen Toelstrup for the information platform. Later this morning, you will have the opportunity to meet the project leaders during the stand-up presentations that will follow. At the same time, it's highly unfair not to mention the names of all the work package leaders. Many of the work packages are big projects in themselves. But I should also mention all those scientists from all those surveys who have contributed to the results of GeoERA. or the participants in the secretariat, and last but not least, the monitoring team that has done mountains of work. Next slide, please. We can conclude that GeoERA is the result of teamwork and the result of many teams working together, if you know what I mean. If you just look closely at this slide, you can also see that in the course of this project, the way of meeting together has changed from physical to digital. However, this change certainly did not stand in the way of the result. Next slide, please. I don't want to go too much into contents and details, but I would like to show you a few numbers on communication and dissemination. At the start of GeoERA, targets were formulated, as you can see in the third column from the left. In the rightmost column, you can read the actual achievements. Visitors to websites, tweets, posts and social media followers, videos watched, participation in conferences, newsletters issued, the number of publications, etc. All these results have exceeded by far the targets that were set, sometimes by an order of magnitude. To me, this seems an exceptional achievement. Okay, in the next few hours, you will learn much more about the real contents and the results of GeoERA. I wish you lots of fun. Thank you. Now I will give the floor to Wolfgang Schneider, who is the Policy Officer at the Clean Energy Transition Unit of DG RTD. Wolfgang has been closely involved from the start of GeoERA. Wolfgang, please go ahead.
Thank you, Joop. Good morning, everybody, and thank you for inviting me to the GeoERA concluding conference. I remember the GeoERA webinar we had in November 2020. This was initially planned as well as a live meeting, but finally it had to be converted into a virtual meeting. Now, more than 1 year later, we are in a similar situation. However, it's good that technology allows us at least to meet format. And I think that is now the way it is done. It is a very good possibility to exchange our views and to meet. In total, 5 years have passed since the start of the GeoERA project, which is funded under the Horizon 2020 Research Framework Program, and it is now reaching its final stage. Today, we will hear about the many successful projects that have been executed under the key areas, energy, groundwater, and minerals, and on the development of a common information platform for organizing, disseminating, and sustaining the results of GeoERA. This platform is for us a very important part of GeoERA because it paves the way for the next challenge. That is the coordination and support action within the new research framework program, the Horizon Europe framework program, and it has the title Support to the Activities of the European Geological Services. The goals of this new topic are widespread and very important. The first one is to work on an improved evidence-based decision-making and long-term sustainable management of Europe's subsurface. And this covers the European onshore and offshore areas. For the Commission, this is an important building block in view of becoming a climate-neutral continent. Here I'm referring to the European geothermal resources, the possibilities to store renewable energy carriers like hydrogen, and to further develop a storage atlas for CO2. The latter one is particularly close to my heart as I spend a lot of my working time with the development of technologies related to carbon capture, CO2 transport, utilization, and storage. To reach the EU climate goals, it is clear that in addition to reducing the emissions of greenhouse gas, we will need the deployment of the full CCUS chain. As this requires storage of CO2 in Europe, a classification system for CO2 storage seems absolutely necessary. And that is why I mentioned as well that we will have to look at onshore and offshore storage possibilities. In that respect, I would like to mention that we have two related ongoing research projects, and some of the participants today, in my view, are even members of the consortia of these two projects. There is, first of all, the project which is called Strategy CCUS, which means Strategic Planning of Regions and Territories in Europe for CCUS. This project will run until summer this year and evaluates at regional and national scale the possibilities for CCUS deployment in southern and eastern EU member states. The second project is called Pilot Strategy, which means Geological CO2 Storage Pilots in Strategic Territories. This project started in May last year and is scheduled until 2026. It is investigating geological CO2 storage sites in industrial regions of southern and eastern Europe to support the development of large-scale carbon capture and storage. Here, the research focuses on deep saline aquifers, which promise a large capacity for storing CO2 captured from clusters of industry. And this is, for me, a perfect example for pan-European collaboration, because detailed studies will be carried out on deep saline aquifers in the Paris Basin in France, in Portugal, in Spain, and researchers will also enhance knowledge of CO2 storage options in Greece and in Poland. Now I come to the second important outcome we expect from the European Geological Services, and that is an inventory of complete and fully harmonized data on primary raw materials, with a focus on applications for energy storage and power generation, resulting in a higher level of independence for the EU. The World Bank estimates that the demand for metals will drastically increase by 2050. The World Bank estimates that on top of the existing demand, we will need the double just for solar applications, the triple for wind applications, and even it will be 10 times higher for batteries. In my view, this is already a kind of humble estimation, and it could even be more. And in addition, the electric mobility will raise the demand for a number of further raw materials, for example, like rare earths. Therefore, this data inventory is very important for us, and it will follow the United Nations Framework Classification System for mineral resources and will be supporting the United Nations Resource Management System and will be as well in line with the UNECE Sustainable Development Goals. The third important pillar are Europe's water resources. They are under increasing pressure because of climate change and competing use of the subsurface, including the mineral and energy resources. All these examples show that there is a growing demand for an up-to-date body of knowledge with high quality, policy-relevant geoscientific information and expertise. And this needs to be aggregated and available at EU level for the benefit of European citizens, enterprises, and institutions. This is clearly a challenge at European level and should ultimately lead to a geological service for Europe. As you probably know, the deadline for submitting proposals was a bit more than a week ago, and the evaluation of submissions will commence soon. I'm glad that the important work to establish a geological service for Europe will start soon, and I wish you great success for this challenge. I thank you now for your attention, and I'm looking forward to hearing about the success stories within the GeoERA projects today. Thank you very much.
Thank you very much, Wolfgang. Our next speaker is Peter Henley. Peter is head of the unit Energy Intensive Industries, Raw Materials from DG GROW. Peter, please go ahead.
Thank you. Can you hear me?
Yes.
Very good. Thanks very much. And very interesting to hear my colleague from DG Research and Innovation. We are working very closely together on all matters relating to the geological services inside Europe. I'm going to make a few slides. If Renata, you could move on to the next one, please. So we rely extensively on the best possible knowledge and intelligence that we can in order to do the analyses that underpin our work on criticality assessments and our work on trying to see what's coming down the road 10, 15, 20, or even many more years down the road. And this is all to serve our policy agenda, which is set out in a range of documents that have come out since the von der Leyen Commission took office a couple of years ago. Most recently, the interesting development was that the European Parliament issued an own initiative report in November, which strongly supports all the different strands of action that we have in the EU Critical Raw Materials Action Plan, but actually encourages us to become even more ambitious and deal with problems that are becoming no less serious by the day. And I talk in a context of very high energy prices, very high shipping prices, logistical problems, health-related shortages of labor because of lockdowns, and most recently, of course, we have a very ominous situation on the eastern borders of the European Union, which also has potential to add another layer of complexity to supply chain resilience. So for all this, the best possible knowledge is absolutely essential. Next slide, please. You're probably all familiar with the work that we've been doing together. Many of you are involved, I would imagine, in the various expert fora which we use to pull this work together. So the last publications we have really assessing the situation Europe-wide are the 2020 criticality assessment and the backup studies and fact sheets on about 85 materials, not just the 30 that we selected as critical. But also, and this is quite innovative, the work that our colleagues at the Joint Research Centre led on our behalf, looking at the outlook for the key emerging technologies that we're going to need, and seeing what this means in terms of possible demand for raw materials with two time horizons, 2030 and 2050. So this covers things like the energy transition, decarbonization of industry, quite a lot of things relating to the digitalization of the economy, and of course e-mobility, goes without saying. Next slide, please. And just to say that before the end of this month, we're going to be launching the work on the next criticality and foresight assessments. So that the sort of the hidden part of the work essentially takes place throughout 2022, and at some point in 2023 we will be issuing the results and probably also taking stock of what has been done so far in response to the action plan that we came out with in 2020. In order to do our work, we rely a lot on different data sources. Some of these are commercial, but as far as possible, we try to rely on publicly available information because this is easier for us then to relay without any kind of things that we have to keep back. Because the more we can use things like Eurostat or public data from the Geological Surveys, and we really appreciate the work that the Austrian government does on world mining data, for example. Your own European Minerals Yearbook is an important source. So let's carry on this good work. Next slide. So our September 2020 communication and the package around criticality and foresight. Also, for the first time when we came out with a criticality assessment, we decided to accompany it with actions. Many of these actions are not novel, and they're very much still in the line of the European Raw Materials Initiative, and we're just trying to give it an extra push because we can see that despite all the actions that we've been following the last decade or more, the situation is not getting better in many respects. It's not getting better because we've seen that the percentage of EU dependency on other countries for critical raw materials has continued to rise, and that in itself is not the problem, but the concentration of our supply on one or two source countries is something which can be very damaging if you have uh, disruptions in the supply chain for economic or indeed for geopolitical reasons. I would say that in more than half of these 10 actions, geological surveys have an important role to play. Many of them are knowledge-based. You can see, for example, the work on mapping the potential supply of secondary critical raw materials, identifying mining projects that could become operational by mid-decade, Earth observation programs. I know you're very heavily involved in that stuff, and all the various research and innovation programs that we're running in this domain. And we also need you. We also need you when we go into strategic partnerships with third countries, but I'll come back to that. Next slide, please. We have set up industrial alliances to help us in a number of ways, which we cannot do ourselves directly. What these alliances can do, and I'm talking batteries, raw materials, clean hydrogen, they can create networks across value chains and going beyond industry towards other stakeholders like member states, regions, the trade unions, yourselves, other research and innovation centers. And these alliances not only build the networks, they identify investment pipelines, and they can also identify for policy decision makers like us here in the Commission, what are the bottlenecks, what are the barriers that require some kind of regulatory or enabling framework solution. So, for example, the Batteries Alliance has been running since 2017, proved very effective. Lots of investments taking place throughout the value chain, and there are two public-private partnerships, important projects of common European interest, which have been put together, multi-member state, going throughout the value chain, including primary and secondary raw materials. My team's also managing the Clean Hydrogen Alliance, which put together an investment pipeline this last year. We published a list of 750 projects in November, and they're also the first two of a set of IPCIs going through DG competition at the moment. And then on the European Raw Materials Alliance, which is our own baby set up under the action plan, we have received from them an investment pipeline of around 11 billion euros, 28 projects in many member states. And this is also, again, throughout the value chain from exploration right through to recycling. And they've also delivered us a very useful action plan on rare earths and permanent magnets. Next slide, please. I think I'm going to have to speed up a little bit. So I'll skip that one. I've already said that. Next slide. Yes, we think it's very important that the market gets the right signals when deciding where to invest. And that's why we have the sustainable financing platform developing a taxonomy to classify what are sustainable investments. One of the areas that we announced in our critical raw materials action plan is action 2, that we want to develop taxonomy for the mining, extraction and refining of raw materials. And this work was taking place last year, but unfortunately was not able to conclude. So we are giving it a fresh mandate and relaunching the work this January, and hope to have criteria by September. Then we'll have to see when this would become part of a delegated act. Next slide, please. We have a very extensive raw materials innovation and research program in Horizon Europe. These are the areas we're studying at the moment, and the key message here is that there are still opportunities to prepare submissions for the work program, which has a deadline of the 30th of March. Again, full spectrum of activities, many of them of relevance to geological surveys. Next slide. And more specifically, this is what we've just heard from the colleague from DG Research and Innovation. we are providing support to your activities. And the key things we need to see are harmonized data on primary and secondary raw materials. And we'd like you to develop a European International Centre of Excellence on sustainable resource management, which is going to be part of a global network which will plug into the United Nations Economic Commission for Europe. Next slide. My team's been working closely with geological surveys and mining authorities to try and make more robust the knowledge we have about the raw materials potential in Europe. And to do this, we're applying the UNFC approach so that we can turn, if you like, raw geological knowledge into a good system for tracking the maturity and the progress of projects across Europe, and particularly focusing on the critical raw materials. Next slide. So we've managed to identify just short of 1,000 projects, of which about 15% we consider are ready to be operational. So that's, if you like, responding to action 5 of our plan, which is what have we got, and which ones could potentially be out there by 2025. Some of these are battery raw material projects like lithium. Next slide. So yes, we would like you to provide advisory support to your national authorities to help them apply the UNFC, because it's very important that we can speak the same language and have the same harmonized understanding of the resources at a European scale. Thank you. Next slide. Earth observation, we're working closely with you on this stuff. And we're also trying to plug this into our strategic partnerships with third countries, because this Earth observation and the services that go with it not only help you find resources, and we see that people like Google, Amazon, Bill Gates, but also the Chinese are looking very much at this kind of tool as a less invasive way to establish the probability of finding interesting resources at a global scale. But it's also good for managing live mining and refining operations, as well as tracking what happens after closure. Next slide. So on the international front, we are developing a series of strategic partnerships. The ones with Canada and Ukraine are in place. Just yesterday, we had a technical kickoff with Serbia. I know Serbia is part of your community. And we also mentioned explicitly that we see for the next phase of this work of developing a strategic partnership an important role for geological surveys on both sides. We have an ongoing partnership with, on a regional basis, with Latin America. And at next month's EU Africa Business Forum, we'll be talking about our pilot activities to develop partnerships in half a dozen African countries. And we know that some of your members are very active in African countries, helping them to develop their geological services, but also helping them to develop better knowledge of the resources that they have. Next slide. And a very important part of our policy agenda is responsible, sustainable mining, in order to provide assurance that when we allow operations in Europe, these are meeting the highest possible environmental, social, and governance standards. So we've drawn up, with the help of the Raw Materials Supply Group, which includes, of course, the Geological Surveys, that we've drawn up these principles, which also show how the principles are applied in practice through the EU regulatory framework. Thank you. Next slide. And just to wrap up, we see a very crucial role for the Euro-Geo surveys, helping us to explore and evaluate both primary and secondary sources of critical raw materials in EU27, but also in countries where we're engaging in strategic partnerships. We help you. We think you have a very important role on the UNFC and the UN RMS side, as I've mentioned, and we'd like to continue working with you to develop a really robust knowledge of critical raw material projects using the UNFC. Help us with the partnerships, help us with the Earth observation, or we help you with the Earth observation. And let's try and work together on trying to provide more reassurance to the public that we can do things responsibly in Europe. Thank you very much.
Okay, thank you, Peter. Thank you very much. Our next speaker is Ruth Chino. He is the Deputy Director of the Directorate Sustainable Heating and Subsurface Policy of the Ministry of Economic Affairs and Climate Policy of the Netherlands. Ruth, please go ahead.
Thank you very much, Joop. Good morning, everybody. At the Ministry of Economic Affairs and Climate Policy, I'm responsible for the mining policies, but also for the sustainable use of the deep subsurface in relation to the energy transition. And I would like to share some experience from the Netherlands in policy making and also in the relation with the Geological Survey. I'm responsible as a liaison between the ministry and also other departments and ministries within the Netherlands and the Geological Survey. And I will explain why geology, in my mind, really matters. So please, first slide. Actually, in the Netherlands, we face a geological information paradox. Because on the right-hand side, you see all the sustainable development goals, and the highlighted ones are the ones in which a geological survey, in my opinion, can make a big contribution in providing information and helping out policymakers and politicians. So actually, you assume that a geological survey is very well known and very popular in your own country. And it should be working for a multitude of governmental departments. And the first thing politicians and policymakers ask for is solid information on which to base their policy. And a geological survey is capable in providing just that, sound, solid information, and give you good advice. But what you see concerning the subsurface, it's not well known. It's out of sight and therefore out of mind. People are only confronted with the geological circumstances when an accident happens, a disaster happens. Then they suddenly realize, okay, something's going on here. In the Netherlands, we have the experience with the production of natural gas from the Groningen gas field. That caused a lot of tremors, and then people become aware of the geological circumstances, and they ask a lot of questions, and they don't trust their government anymore. And this has caused a reaction. This has given a reset in the mindset of politicians, because they are now really interested in the geological circumstances and the advice from our Geological Survey. And all the time it was there, but it was, if we might say, hidden in plain sight. They have a lot of information, but it was not used by a lot of policymakers and politicians. And this is about to change. So let's move to the next slide, please. Because politicians have to realize they are living in the fast lane, and they are always looking for quick solutions to immediate and urgent problems. And they have to realize that the geology has a different heartbeat. It is based on years and years of data collection and interpretation. The existence of the Geological Survey in the Netherlands is more than 100 years. Was it established? More than 100 years ago it was established. And that means that they always will give you an evidence-based and strategic advice. And politicians have to realize that it's not a quick solution, but it's the real sound information you need to make the best decisions. They have to also realize it's a cumulative science. Always new data are added, new information is added, and this will resound in the advice a geological survey will give you. Also, what should be realized is that the data and the data collection is very costly, because most of the data are provided by companies who did drilling and send in the cores of the drilling, the bore holes, which was interpreted by the Geological Survey. if you can't make use of the data that way and you have to get the data yourself, it is very, very costly. So we always say make use of the circumstances and make sure that all the data which are collected by private companies or governmental organizations, make sure they are collected and interpreted and stored in a database. Which also means those data are so costly, they should be managed accordingly. They should be managed very well. And also the quality control is key. Next slide, please. Therefore, we are of the opinion that an institution to do all this work. And ideally, all the tasks mentioned here should be integrated, should be within that institution, should be within that organization. And also this organization needs to be independent from government policy. It should provide information, it should be scientifically independent. What you need is also making use of the latest technology. Implementing the latest technology on digital geology, model making, the quality control, and also maintaining the knowledge base is something that needs special attention. And for this, you need a dedicated organization. They should do the data collection, they should do the interpretation, they should build the databases, they should make the models, do the mapping, and also make sure that they maintain the knowledge base. What's nice to see is that every country has a geological survey. And as just mentioned, geopolitical reasons and making access to raw materials available is of course a very important driver to have a geological survey. You see them on national levels, federal levels, regional levels, and they are typically 100 to 200 years old. So we have not a very special geological survey in the Netherlands. It's actually the same what you see everywhere. But the mandate and the capabilities, they vary. And this means that there's a lot of opportunity to collaborate, share experiences, and learn from each other. And therefore, in the Netherlands, we applaud the ideas of looking for a European geological survey. Let's go to the next slide, please. In the Netherlands, our geological survey is part of a much larger organization which is called TNO. And actually TNO is the Knowledge Institute on Energy and the Energy Transition. The Geological Survey has 250 full-time equivalents of working power, so to speak, and they have an annual budget of 40 million euros a year, which means they are quite well organized and quite well funded and provide a lot of information. As you can see, they perform the task which I mentioned before, and also they pay attention to new developing fields as geoenergy research. Think of geothermal energy, because we need a lot of data about that. And also they do geoenvironmental research. Because the energy transition, of course, is very important and should help to make the change towards zero carbon emissions. But beside the positive effects, there is also a downside, because you introduce new hazards and risks into society. Think about hydrogen, think about the storage of hydrogen, but also if we drill for water, for geothermal energy, people in the surrounding area will ask a lot of questions because they are worried what's about to happen. So those new issues need to be addressed, and that's why it's very important that the Geological Survey is integrated in a large institute with a lot of knowledge about the developing technologies, and that they are trying to collect also data which can be used in addressing the risk and hazards of those new developments. Next slide, please. As I told you, our Geological Survey is well resourced. And also we have the benefit of being a very small country and a centralized organization as a geological survey. I think we are one of the few countries that has a complete 3D map of its total subsurface. That's also because we had a lot of production of oil and gas in the Netherlands, which means that a big part of the Netherlands already has been explored and the data has been collected. So it gives us a unique position and also possibility for the whole country to give a 3D picture of the subsurface. But it's also important that all this information can be shown to the public and find its way to the decision makers. Therefore, I'm very happy that our Geological Survey is investing in digital geoscience, because that's also a way to make data available to a huge public. And also the maps and the models are accessible for the public and for policy makers and decision makers and find their way in the decision making. Next slide, please. The Geological Survey in the Netherlands is aiming to provide data and advice for different ministries. First, the Ministry of Housing. They are responsible for our built environment and the realization of lots of residential homes. And they need information about foundation construction. So the Geological Survey provides data about for the built environment, and it goes tens of meters deep. But they also give information to the Ministry of Environmental, the Ministry of the Environment, and that's concerning the quality of groundwater. And then you need data going hundreds of meters deep, because that's where the aquifers are in the Netherlands. And then you have the Ministry of Economic Affairs and Climate Policy, for which I work, and then they provide information concerning the energy production, but also the storage of energy carriers, and this goes thousands of meters deep. Actually, here you can see the 3D literally translated to different ministries and different responsibilities. And also, which is of course important, is when you try to produce energy, you have to drill through the bottom layers. You can't do it in the built environment, but also other areas might be very sensitive because they have natural habitats. We need to respect that as well. And also you might penetrate groundwater bodies which are used for producing of drinking water. So you need this integrated, you need to look at the whole picture all the time to give good and sound advice. That's why the Geological Survey is regulated in a legal context, first of all by the Mining Act, and connected to the Mining Act are also the environmental issues concerning mining policy and making use of the deep subsurface for the energy transition. But they are also regulated by a key register for the subsurface, and this is a new instrument. They provide unique data which are available to the public, and this is very important. Governmental bodies are obliged to use this data. So they have to base all their decisions in construction, in making decisions about what can be done where, based on the information in this key register. You can compare it with a database with all the addresses of all the people living in a country, which should be maintained very well and is a key register. And this is the key register for the subsurface. So all the data are collected and shown to the public and have to be used by government. Next slide, please. What the Mining Act is regulating is actually the transfer of data which are collected in the exploration and production by mining companies to the public domain. Of course, those data collected by the E&P industry are confidential, but after a couple of years, I think it's 2 years, they should be made available to the public and also can be used by other companies. And this has been done in the time that the Dutch government was very interested in making use of the resources that were there in the Netherlands, most of the time it was natural gas. And of course, providing this information also to other companies made sure that everything was explored and that we extracted the optimum amount of gas from our subsurface. But now we move away from that. Now the fossil era comes to a conclusion. Now we are going to make use of this subsurface for the energy transition. And important in this is that the Geological Survey is in a unique position because they have a designated task in getting the information, interpreting the information, and show it to the public. Because they have this unique position, they are the only ones who are doing this. Actually, their annual turnover and the maintenance value of their activities is in the range of tens of millions a year. So they save a lot of money, a lot of public money. But the combined value of all the data they have collected, which are stored in the database, is tens of billions of euro in value. And it is very important to realize this. So you're sitting on gold and you should handle it with care. Next slide, please. Already said something about this key registry. The subsurface data are acquired for government, so they are in the public domain. They are registered, stored in a single register, and they have to be used by governmental bodies. What you see is that we have a positive business case for this because it helps to reduce the cost of failure in construction, and it also helps in solving other problems. For instance, drought, and if we have excess water, you should also make good decisions which can save a lot of costs. It was an investment to build this register and to store all the data and invest in the streams of the data collection and interpretation, quality control, and making it available to the public, an investment of 50 million euros. But we have already indications that it's really a recovery time of 2 years, we will have our investment back. So we reach a break-even point in 2 years' time. So this shows that a sound investment can be made in public data, in the use of public data, and it will save a lot of cost for society. Next slide, please. What are our experiences and lessons learned? Of course, the Geological Survey say the scientific excellence is a given, but you can't dwell in that. It's not enough. It's the organization of a geological survey that makes the difference, because you have to organize the information streams from data collection to the other end, providing data to the public, and not only just the data, but also the public should be able to understand the data. So you also have to give them advice and show them how the data should be used or what the data are telling you. But you also have to be in contact with your stakeholders and users. And this is, of course, asks a lot of the organization and the competence of the staff. You should be able to ask your stakeholders and users what they are looking for, and you should be able to translate it to what you're able to provide. And then you should maintain the contact with those stakeholders and users. You should check if it really helps them in solving their problems. So you need to stay attuned to the societal needs, both from government, industry, and perhaps most important, all the citizens, because the energy transition comes into full view of all the people. They see windmills, they see drilling for geothermal energy, and they are asking themselves, is this really safe? What are the benefits? Is the government making good decisions? How can we be involved? Is there room for a cooperation in which we take part in those projects? Those are the new users of information of geological surveys. Next slide, please. And here you have the changes in one chart. On the left-hand side, you see the changes in society. On the right-hand side, what it means for the Geological Survey. I start with the trends in energy. The energy transition, of course, is there, but what we see is where we were used to centralized production of energy and distributing this to the end users, now it's more decentralized production of energy, which gives a lot of stress on the network, but also it makes sure that a lot of people are now seeing what's happening and it's in their face. So there's a lot of public concerns. That's the big change we see in energy. And what this means for the geological surveys is that the subsurface is used in a new way. This means new expertise for the staff, for the organization. And you get
Good, we are
all
running
kinds of...
a little bit out of time. Okay.
Okay, I'm going to finish.
Thank you.
And you need a lot of new dialogue. In water, we see the trend that we had excess water, and now we see more and more shortages of water. This also means more cooperation with other institutes. And in the built environment, we are confronted with a shortage of housing, and that needs to be solved. So there are a lot of data provided to the Ministry of Housing. I think we're going to the last slide, and then I will conclude this presentation. Of course, for this to do in a good way, you need adequate funding and also a structural funding. As a reputation, the Geological Service needs to be independent and needs its authority, and it needs to be well connected. Next slide. And this is the giveaway message. Those best national practices can be integrated also in the Geological Service for Europe, where we have the advantage of scale, where we know that geology doesn't stop at the border. We already saw the geopolitical side, that raw materials are produced for one single market. And also think in Europe we share the same goals for quality of life and environment, and also scientific progress. So let's make it happen. Thank you very much.
Okay, thank you very much, Ruud. Well, now we have a look at the 4 team coordinators who will give a brief introduction to each of their themes. Afterwards, in the parallel sessions, you can get acquainted with the individual projects, but first let's give the theme coordinators the floor. Serge van Gessel from TNO, please go ahead.
Yes, thank you, Joop. And I will present briefly the GeoEnergy team, but I will first start with a general model which we use as geological surveys to establish an essential value chain between research and innovation on the one hand, and policy and services on the other hand. Within the national and European projects, we perform research on novel concepts and technologies aimed at renewable, sustainable uses of the subsurface. And this includes renewable energy, protection of groundwater, and accessibility of critical raw materials. Our activities are aimed at assessing and exploring the feasibility and conditions for sustainable exploitation, and which results in novel information products and extension of our knowledge base. This information and knowledge base is then used to develop services for policymakers, other stakeholders in society at large to support decisions and to enable responsible exploitation and protection of the subsurface resources and capacities. And while new subsurface uses are developed and monitoring takes place, new information is being generated, which is subsequently collected and analyzed by the Geological Service and embedded in the new research activities. The GeoERA projects and teams are all part of this integrated value chain, and today our community will present the latest results we have achieved over the past 3 to 4 years. I will now briefly go into geothermal energy, or in GeoEnergy, but I will keep it very brief for the sake of time. In energy, we have in our scope geothermal energy for heating and cooling, and also decarbonizing industry sectors. Energy storage for balancing energy demand, but also securing energy, CO2 storage, which is essential for achieving the climate goals, and natural gas, which is a bridge fuel for the energy transition. We provide harmonized prediction of geoenergy resources and storage capacities In GeoERA, we improve the detection and anticipation of synergies and potential bottlenecks like hazards and environmental impacts. We have deployed our information in state-of-the-art decision and support and subsurface management planning tools, and we were asked to enable and improve the dialogue with stakeholders, societal organizations, and public. Above all, of course, we provide a foundation for the development of the geological services of Europe and paving the way for future research and innovation programs. Within a short moment, you will see examples of the 6 GeoEnergy projects, which are focusing on developing a 3D digital twin of Europe, capitalizing information and knowledge from the oil and gas industry, among others for CO2 storage and energy storage, providing novel information platforms for stakeholders to enable and responsibly manage shallow geothermal in urban areas, to unravel the potential for the development of geothermal plays in Europe, but also reduce exploration risks, to develop a state-of-the-art database for analyzing information about subsurface faults, but also assess hazards and impacts, and to provide the first-of-its-kind framework and tools to support subsurface management and stakeholder dialogues across different teams, scales, and expert levels. We have done a lot in our team. We provided evidence-based and unbiased decision-making information, fair data, scale-independent methodologies, novel tools which unlock and analyze and manage subsurface potentials. We have been able to reduce uncertainties through our collaboration and also development of harmonized methods, but we also contribute to the prevention of avoidable costs due to unwanted environmental hazards and also a better understanding of critical geological structures and exploration risks. We extensively participated with stakeholders and decision makers, and then therethrough we have achieved a better integration of geoenergy technologies in the green transformation of the energy sector. And last but not least, we contributed to a better informed society and science community through a lot of social media outreach, stakeholders and science events, and capacity building. With that, I would like to end my presentation on geoenergy, but please visit the energy breakout, and I will give the floor now to my colleague, I believe, Antje or Klaus.
I think that will be Antje.
Yeah.
But first, I would also ask the attention of the audience that we have a Q&A box that you can use whenever you have questions or remarks. You can enter them in the Q&A box, and we will take it up, and that will be used during the panel discussion later on. Thank you. Please go ahead, Antje.
Thank you. A warm welcome also on behalf of the raw materials team. This morning, Peter Handley, but not only him, stressed the importance of raw materials for the prosperity of a society. This importance has been emphasized many times in the European Union in recent years, and it has therefore also the starting point for the raw materials as opinions. And now I'm frozen? No. Extending, deepening and upgrading the quality of the pan-European primary and secondary continental and marine resource inventory, updating contributions and augmenting the coverage of the annual minerals yearbook, performing pilot studies, supporting exploration and development of mineral raw materials, and implementation of innovative and efficient approaches throughout the mineral raw materials value chain for an enhanced management. In doing so, GeoERA Raw Materials supports efforts to enhance the responsible sourcing of mineral raw materials from European deposits. GeoERA Raw Materials approaches the common goals from 4 different perspectives. Eurolitus, the beauty, compiles important rock parameters in a coordinated way and highlights the importance of ornamental stones for our cultural heritage and local wealth provided by sustainable raw materials. Frame, the lighthouse on strategic and critical raw materials, is designed to provide new data and models and concepts. Sea, the flagship, provides science-based details on marine raw materials in the European seabed. And Mineral4EU is the core project regarding a reliable and coherent European raw materials database. These 4 projects have received a lot of attention right from the beginning, and they have worked very productively and closely together ever since. So they have provided many products, and many of those are the first of their kind. They range from thematic maps to atlases and databases. The comprehensive mineral resource data platform for the European primary and secondary mineral resources with a user-friendly portal is one of these products. It also benefits from the standard structures and schemes for the provision of information. The UNFC system has been applied and mineral qualities and deposit types classified. Mineral deposits, geology, and potential for rare earths, lithium, cobalt, and graphite were compiled in an aggregated form. And for the first time, it was possible to produce deposit clusters and metallogenic information. Pan-European predictivity maps and maps on marine deposits open up a new dimension for the management of Europe's raw materials potential. Numerous guiding documents, case studies, and best practices complement the knowledge base. They range from procedures for preparing samples and ensuring internal consistent geochemical data at European level, the assessment of non-economic values for ornamental stone resources, to historical mining sites either of touristic interest or regarding the potential for critical raw materials. Accomplished by information on reporting standards and legal basis on raw materials from marine deposits. Some of these results are already used by the European Commission, such as the annual Blue Economy reports. The high-quality research results are presented in peer-reviewed articles at international conferences and trade fairs such as the PDAC, and more to come. A wide range of information is also of great importance to maintain the developments and excellency of the network. Others might be of interest as well as to the Geological Survey Organisations themselves. This information is currently being compiled in the GeoERA Raw Materials monograph. By the way, this is in line with recommendations by external experts witnessed hereby. GeoERA Raw Materials is a coherent task force of scientists made by people. They provide a strong expertise and a good linkage between the projects. Despite the hurdles caused by the pandemic, the network of experts has been further expanded also across the Atlantic and Pacific. Fragmentation in research and innovation has been reduced, and continuous improvement in the quality check data made available. All in all, helping to unlock Europe's raw materials potential and paving the way to reduce the import dependency while taking our responsible share in the raw material supply chain. Given the time, this presentation can only give a very brief insight. Further details can be explored today and by visiting the respective project website. And last but not least, thank you for your interest. Thank you. And I hand over.
Thank you, Anja. Thank you very much. The next one is Klaus Hinsby. He's from the Danish GEUS. Go ahead, Klaus.
Klaus, you're muted.
Good morning, all. Can you please confirm that you see my slides in presenters mode?
Yes, now it is.
Okay, thank you. Sorry, I thought while you were going to unmute me. So, good morning to you all. I'm happy and proud to be able to introduce the 4 GeoERA groundwater projects. And their research and information products. The 4 projects were developed by the partners from nearly 100 project ideas in the early phases of the projects. And all 4 projects provide important and easily accessible information for sustainable groundwater management under climate and global change, and increasing use of the subsurface, thereby supporting EU and UN policymaking and implementation. Too much, too little, or too polluted are the 3 main questions to answer or in other words, large variations in groundwater quantity and quality in time and space, are the main and continuously increasing challenges that we deal with. And we do that to protect the water resources for society and nature on a changing planet. Sufficient groundwater of good quality is extremely important for societies, ecosystems, and biodiversity globally. Too much or too little water endanger food production, biodiversity, the built environment, and may result in floods, droughts, landslides, and land subsidence, and other geohazards. So this slide illustrates the topics of the four GeoERA groundwater projects, their contributions to the Common Information Platform, sustainable groundwater management, EU and UN policies. The groundwater projects develop research and information products from local to pan-European scale. From the top, we have the HOVER project on groundwater quality, developing studies on degradation of contaminants at selected points in the groundwater surface water transition zone, groundwater vulnerability to pollution from the surface at European scale. Below, the resource project on groundwater quantity, studied locally karst and chalk springs and aquifers, and developed the pan-European groundwater resources map on depth and volume of groundwater resources at European scale. Below, we have the TACTIC project on groundwater and climate change, developing, for instance, and investigate saltwater intrusion in coastal aquifers at local scale, and groundwater recharge at local to pan-European scale. Above TACTIC, we have finally the GeoERA project on groundwater vulnerability to deep energy-related activities that develop conceptual models and decision support tools for assessment of groundwater vulnerability to energy-related activities, and reports from pilot studies in Belgium, Hungary, Netherlands, and the UK. So examples of contributions for expected GeoERA groundwater impacts according to the GeoERA grant agreement include improved access to downloadable groundwater quantity and quality data at local to pan-European scale, as mentioned, and examples include also, as mentioned, water volumes and aquifer characteristics in European aquifers, groundwater quality in European aquifers, here it's arsenic above the drinking water standard, state-of-the-art tools to support sustainable decision-making in relation to the water, food, energy ecosystem nexus or interrelated resource systems. Examples include nitrate in the unsaturated zone infiltrating to groundwater. And again, decision support tool for assessment of groundwater vulnerability to deep energy-related activities. Further examples of contributions for expected GeoERA groundwater impacts according to the grant agreement include also tools for assessment of climate change impacts, mitigation, adaptation strategies. And climate change, of course, is an example of the nexus, exploitation of hydrocarbons in the subsurface, increase the CO2 in the atmosphere, change the climate, and the precipitation patterns, which again affect the groundwater resources and nutrient export to ecosystems, associated ecosystems. So tools for assessment of climate change include average groundwater recharge for Europe, as well as measured and simulated historical, current, and future recharge at different scales and climate change scenarios. So here we see for Spain, national scale, and at local scale for historical groundwater level estimates or measurements, and also future projections of groundwater levels at different seasons at different climate change scenarios. Finally, we also create opportunities for collaboration with private companies and research institutions to develop new EGDI add-on services or information platform add-on services for groundwater. Examples include 3D geological models and visualization of these for hydrogeological assessments and real-time measurements of groundwater levels. So thank you for your attention. Please visit the website, and you will now hear more from the project leads of the groundwater project. Thank you.
Okay, thank you very much, Klaus. I will now give the word to Jürgen Tulstrup, also from GEOS. Thank you.
Yes, thank you, Jo. I would like to try and share my screen now. I think, Klaus, you're still sharing your screen. Thank you.
Yeah, no, it's fine. No.
Oh, sorry. I hope you see my presentation now.
It's okay.
Okay, yeah, I will talk about the GeoERA information platform theme and also the project. They are actually more or less the same. I will speak in this very brief introduction about the background for having this theme and this project and the objectives of it. Then in the specific session later this morning, I will go more in detail with how we then set up the project and the results of the project. So the background, a very important background for having this specific project and theme under GeoERA, in addition to the scientific ones we just heard about, was that it was realized about 10 years ago that too much money has been spent on geoscientific data and harmonization projects, because almost all of them are stopped to function in an online way a few years after they end the project. So a lot of money is going into creating data, harmonizing data, and so on, but it disappears after a few years. We didn't want that to happen in GeoERA, so that's one of the backgrounds for the project and the theme. Another one is that it's very central for GeoERA, which was described already in the call text, that we should work across the different 3 scientific themes we just heard about. So it should be possible to analyze geological data across them. It was also very obvious from the beginning that what these projects needed in terms of creating databases, making access to data on maps on the internet and so on, were very much to a very high degree the same. So we didn't want them to waste money on developing the same functionality and databases and so on in all the different projects. We could do that smarter in one project. We also already had the European Geological Data Infrastructure, EGDI, which already before GeoERA contained a lot of the functionality we could foresee would be requested from the other projects. EGDI was developed and launched in 2016 and developed by Geological Surveys, so it was already there. So the conclusion of this was that we needed this specific theme and one project under that theme. So what were the objectives of this GIP project and theme? Yeah, as I said, it was first of all to support the other GSPs. We call the GSPs as the GeoERA scientific projects. So we under the 3 other themes, we were there to support them, to organize their data, to make the data more standardized so they're more useful, to disseminate them in a easy way for the users to use them, and to also, very importantly, to safeguard them after the GeoERA ends. So overall, we have on the left the 3 themes with the 14 geoscientific projects. They are delivering information, data products, and so on to the information platform, which then stores them and makes them available in, that's just one example here shown, a map, but there are many other different forms of disseminating this information. We also had as an important objective to support cross-project and cross-domain analysis, so putting together the information so that scientists could work across the different projects and domains, so treating the information in the same way. Then we have had a lot of focus on what is called fairness, that the principles which are very common nowadays, that data must be fair, meaning they should be easy to find, they should be easy to access, they should be interoperable so they can be used together with other information, and they should be reusable, so not too many restrictions on what you can do with them. This has been a very high focus point for us. And then we also really wanted to do this with a high quality and cost effective. So that's why for instance, we're building on the already existing EGGI. A very important objective is that the knowledge base, the overall knowledge coming out of GeoERA as such, should be in this platform. So that's the backbone of the overall knowledge base. I'll stop here and continue with the more details about how we then work in the project and the results in the specific presentation, which will come later this morning.
Okay, thank you very much, Jürgen. Okay, first, for the audience, I would like again to point out that you can drop questions into the Q&A box, which can be seen on the right hand of your screen. And now I'm going to invite you to go to the presentation by the individual GeoERA projects. 3 sessions will run in parallel for GeoEnergy, groundwater and raw materials, and you may choose which one you want to watch. You will be able to join the sessions very shortly by clicking Virtual Stand-up Presentations tab on your left side menu. You can do it now.